בכלל לא צריך פרומטר.
Hi, everyone. Thanks for joining. We're going to take a couple more minutes to let everybody in, and then we're going to start. Okay, welcome everybody. My name is Solal. I'm from the delivery team in Wiz. And with me today I have Nir and Shir, if I'm not mistaken, on the camera, from the research team. And we'd like to talk to you about ChaosDB, the new vulnerability in Cosmos DB in Azure. As you might have seen in our recent blogs and publications, we recently found an unprecedented vulnerability called ChaosDB over in Cosmos DB service in Azure. And we're going to review the discovery today, how it impacts you, what you need to do to validate and mitigate the vulnerability, and how to review it in Wiz as well. So without further ado, I'm going to pass it over to Nir. If you might have any questions, please open the Q&A, not the chat, just the Q&A. And we're going to either respond live or stop Nir to take some questions.
So, hey everyone, my name is Nir. I'm a security researcher here at Wiz. One of the guys who researched the ChaosDB vulnerability. And this is what we're going to talk about today. We're going to talk about what is ChaosDB from the researchers with some undisclosed, with some new details that we didn't disclose in our blog post. How to mitigate ChaosDB using Wiz, and any further mitigation you can do to stay safe from this kind of vulnerabilities in the future. So who is the Wiz research team? We are a group of experienced security researchers wanting to uncover new attack surfaces in the cloud. This year, our team have presented both in Black Hat and DEF CON. Our main focus is cross-account and cross-tenant vulnerabilities. We believe that cross-account vulnerabilities is a new, unexplored attack surface that exists only in the cloud and is one of the main concerns in cloud security. So yeah, that's us. So what is ChaosDB? ChaosDB is an unprecedented account takeover vulnerability in Cosmos DB we've reported in August 2021. Due to the vulnerability severity, Microsoft issued a patch unusually fast, only 48 hours after our report. But even though the vulnerability is fixed, customers are still required to take actions for mitigation, which we'll cover in this webinar. So why did we start research Cosmos DB? Well, every network hacking operation goal is the database. Every hacking event you hear about in the news involves some kind of data leak, ransom, intelligence, which is all stored inside the database. This is the holy grail for hackers. We've seen that Cosmos DB is very, very popular among Wiz customers. And our original research goal was to find some common misconfiguration, so we'll be able to show that in the product. But you know, one thing led to another, and here we are with ChaosDB. Well, let's take a quick overview about the vulnerability. Cosmos DB instances usually come bundled with a Jupyter notebook for development convenience. This means that every Cosmos DB with a Jupyter notebook enabled excuse me, for every Cosmos DB with Jupyter Notebook enabled, a new virtual machine is spawned containing some Cosmos DB related secrets, including the Cosmos DB primary key. Those virtual machines are segmented to regional clusters. Like East US have a cluster belonging to some Cosmos DB notebooks, and the West US has different cluster. So due to a series of misconfiguration, we were able to take over all Jupyter notebooks inside of our cluster and obtain their Cosmos DB secrets. The exploitation of this vulnerability is extremely simple and trivial, which raises the bar for how severe it is. Very, very trivial. Okay. So let's assume an attacker wants to access your Cosmos DB instance. All he has to do is set up a malicious notebook inside your target region. If he knows that your Cosmos DB instance resides in East US, all he has to do is spawn up a new Cosmos DB instance with Jupyter Notebook enabled in your region. He has to jailbreak the notebook, query some information about your target notebook within the network, leak your secrets, and connect via multiple attack vectors as seen in this animation. So we've set up a small demo to demonstrate the vulnerability. As you can see, there are two accounts. There's Sagit Tzadik account, the attacker account on the right, and Nir at nirorfeld@gmail.com, which is the target account containing demo victim 1 database account. So let's play the video. So as you can see, Sagit Tzadik is inside the Wiz organization, while Nir is not inside the Wiz organization. But as you can see, what is common about those accounts is the region. Both resides inside the East US region. But okay. So as seen in the video, Sagit Tzadik has no permission on the target database. So the attacker navigates to the Jupyter notebook and opens up the terminal. Inside the terminal, as you can see, the attacker runs at low privileges as Cosmos user, not root or anything like that. And as you can see in the etc password, there's our user, Cosmos user, which all Jupyter notebooks run in those privileges. Jupyter notebook main purpose is to run some Python code. So we wanted to verify that the Python runtime also runs as the low privilege user. And as you can see, as expected, the Python runtime runs in the same low privileges. But if we switch over to the C# runtime, what we surprisingly discovered is that the C# runtimes actually runs at high privileges, root privileges. In the previous code snippet, the 5-line code snippet seen here actually adds a new vector account named root number 2, which runs with the same UID and GID as the root user to the etc password file. So after running those 5 lines of code, if we go over back to our terminal and observe the etc password file, we can see there is a new record added named root number 2 with the UID and GID of the root user. An attacker can now switch users to the root number 2 account, enter his previous defined password, and run at root privileges. Now this privilege escalation is very simple. So now what the attacker can do is to view the inner firewall rules inside its notebook. And after listing the inner firewall rules using the IP tables command, what we've noticed that there is along with some endpoints and a deny condition on accessing any instance in the 10.0.0.0 subnet. So after scanning the subnet, sorry, I'm getting ahead of myself. Because we have a root privileged user, we can flash those firewall rules and actually access those endpoints. After scanning the subnet, what we've discovered is that this is the subnet containing other customer notebooks virtual machines. And using our exploit, we can take over them. As you can see, our exploit actually takes as an argument the name of the database we want to take over. This is not required. This is our precaution to make sure we are not accessing other Azure customers' database data. But actually, using this exploit without any arguments, we can access every notebook in our cluster and access and take over it completely. Also noting, this exploit screenshot is censored due to the Microsoft request of not disclosing details about the network subnet because it affects other Azure services. But after the exploit ran successfully, we actually obtain the target database CosmosDB account key, as you can see here. And if we go to the Azure portal of our target account, we actually see that this primary key is the same key we've extracted using our exploit from an entire different account. So this is our exploit. As you can see, it was very trivial. 5 lines of code to escalate our privileges to root. And later on, you will see how easy it was to actually take over the notebook. So after compromising the notebook and obtaining the secrets, we can access the data stored in the CosmosDB in multiple channels. We can access the CosmosDB instance directly. We can access it via the Jupyter notebook, which also has a token which resides inside the notebook VM. Or using blob storage data, we can actually edit and manipulate existing notebook which is inside the Jupyter notebook. As the same animation from before, now it's more has more context. We can actually connect to the CosmosDB directly. We can access it via the Jupyter notebook, or we can manipulate the notebook storage found here. So first of all, who is affected? Every CosmosDB with Jupyter notebook enabled is obviously affected and should regenerate their keys immediately. But CosmosDBs created after February 2021 had their Jupyter notebook enabled by default. So they should regenerate their keys also. But who was notified? All customers that had Jupyter notebook enabled only during our research period, which lasted less than a week, got an email from Microsoft that they should generate their keys. But our recommendation is that you should regenerate your keys regardlessly. Besides it being a best practice, you can never be sure that this vulnerability was not exploited prior to our report. And if an attacker can leak those keys, they can always be used at a later stage, as though those are long-lasting secrets. So what is the vulnerability timeline? We've discovered the vulnerability on August 9th and sent an advisory to Microsoft on August 12th, 3 days later. 2 days later, only 48 hours after we've sent the advisory to Microsoft, we've noticed that the notebook feature has been disabled in CosmosDB. And 2 days later, Microsoft got back to us with an email reporting confirming our reported behavior. And on the same day, we've noticed that some of the secrets we've obtained during our research were revoked. We got a $40,000 bounty from Microsoft, which is the maximum bounty you can get from the Azure Bug Bounty program. And on August 23, we actually got a confirmation that Microsoft had several thousand of their customers impacted by our vulnerability. And 3 days later, we publicly disclosed alongside Microsoft. And as you can see, we got worldwide coverage, which is appropriate for such severe vulnerability affecting many Fortune 500 companies and thousands of Azure customers. Ami, do you want to talk about mitigations.
Sure. So before we switch to the second part of the talk, we can, if anyone has questions on the research piece, we have the researchers here, so we can stop here for a few questions, and then we start the mitigations. So I'll give you a minute. So any
We have a
questions?
couple of questions in the Q&A, Ami. I'm going to read them live. First one is, does the exploit need Jupyter Notebook to be exposed on the internet? How does Cosmos DB firewall prevents this attack if it does?
So the exploit does not require the Jupyter Notebook to be exposed in the internet, as we are taking over the Jupyter Notebook from inside of the cluster, actually accessing from inside of Azure. So it's not relevant that it's not accessible from the internet, because our notebook is accessible from the internet. But how does a Cosmos DB firewall prevents it from this attack from happening? This actually depends a lot of how did you configure your firewall. As we observed from many environments, a lot of customers are allowing traffic from Azure. So as we are a legitimate request from the notebook, at some cases we can actually bypass the firewall, or attack another attack vector from the notebook storage, or from the Jupyter Notebook. The second question, another question, Solal, they want to read the.
I answered another one in just in text. The second question to answer live is, did you use Python 2.7 for your exploit file because it was present on the notebooks?
Python 2.7 was presented on the notebooks VM alongside Python 3. We just feel very comfortable with Python 2.
For me, it's comfortable with 3. Okay. Yeah, got it.
Perfect. Great. So now we switch to the second phase of the talk. This attack vector, as we said, is a vulnerability that has an impact on Cosmos DB accounts. So now I'll do two parts of the mitigation. First of all, in general, what is the recommended mitigation for this? And the second would be, how can we use Wiz in order for customers to actually mitigate? Because of course, Wiz provides amazing visibility and deep analysis of the environment, so we can really help you prioritize and pinpoint what are the databases that you have to fix and regenerate keys for, and so on. So as we talked, this timeline, and this is important for the mitigation. Basically, the disclosure was in August 26th, right? And that same time, basically, is the time where we say we should make sure that all databases after the disclosure timeline actually did key rotation, because that means that we know for sure they don't have potentially exposed keys. So if we look at how do we mitigate ChaosDB? So I would say the following: everything that we're going to say assumes that no one actually accessed your data, right? In terms of accessing data in the past, obviously that has no mitigation. The only thing that we can do is monitor, and we can talk about that a bit as well. Monitor in the past logs, the diagnostic logs, on was there any suspicious access from keys, right? So that would be a step that would be more past, looking into the past. The mitigation that we talk about here, the goal of the mitigation is to say, okay, assuming someone got access to the key, right? Let's regenerate the key so they won't have long-lasting access to our database, right? Because what we are saying is, okay, if they got our key and we are not doing this remediation right now, the attacker might be able to continuously use the key even in the future, right? Even though Microsoft took down the notebook service completely, I would still be exposed because the potential attacker got my key, right? So the focus of the mitigation, and that's the 3 steps we're looking at, is basically reducing the risk. It doesn't take off the risk completely, but we're trying to reduce it. So number 1 is to discover Cosmos DB accounts with Jupyter Notebook enabled. Why is that important? Only those accounts are actually the ones that are susceptible to the vulnerability. Because if it's a Cosmos account that didn't have Notebook in the past at all, then there's actually no risk here, right? Because it was not susceptible to the vulnerability. The only problem is it's pretty hard to detect, to understand those databases. It's not fully documented how to do it. And there's no public documentation exactly how to detect database that was ever using Jupyter Notebook. We found several ways. Some of them undocumented, and we will present them, and we actually also built them into Wiz out of the box for you, right? So number 1, find those databases. Number 2, alert the owners so they have to regenerate the keys, right? And we'll talk about that a bit. And the number 3 is also, again, this is a good compensate control, which is important. If you can't, let's say, replace your keys immediately, and it's always good to reduce network exposure of your databases. So we'll talk about all of those 3 in general, and then we'll do it specifically for Wiz.
A quick question. We answered a couple in Q&A, but one I wanted to bring up live. Can Jupyter Notebook connect to any other Azure services? Should we as a customer worry about other services?
So I would say the following. No, it's like the Jupyter Notebook that was discussed here, to the best of our knowledge, only had access to the Cosmos DB accounts, because it was a feature working for Cosmos DB accounts. Now, for the larger question of impact on other Azure services and so on, that would be a bit out of scope for our research, right? I mean, because there might be additional impact, but for this specific vulnerability, these Jupyter Notebooks were only attached to Cosmos DB environment, and the only keys that we found there were for Cosmos DB accounts. So the only risk right now, the direct risk, is Cosmos DB. So that's what I can say for sure. For the collateral risk, that's actually something that we should eventually ask Microsoft. Any more questions? Okay, great. So let's start phase 1. So how do I discover all affected Cosmos DB accounts? Now, we found 2 ways. Again, both of them are undocumented. I agree that it should be documented, but it isn't. So we've done our best to help customers, and we are building that into the product. So you have it out of the box in Wiz, a detection of is my Cosmos DB susceptible to the vulnerability? Was it ever exposed to the notebook service, right? And again, why is this the main question? Because only if it was susceptible to if it was using notebook, the key was copied to the notebook environment, so the potential attacker could copy that, right? So that's why it's a key question. So the method that we found, which is pretty easy to check, is basically NS lookup, the name of the database, notebook Cosmos Azure com. That's basically just a check. If you get an answer, it means that you had in the past a notebook service attached to your database. If you don't get an answer, it means that it was never used and there's no risk in that database, right? So if you get an answer, there is a risk. If you don't get an answer, there is no risk. And so if you want to create a list of databases that should be rotated, basically if you run this NS lookup, a very simple command on all of those, you immediately get the list of those that might be affected and that you need to replace. So it's pretty simple, check. And again, it's undocumented, but we've done testing for that. It seems like the most, I would say, resilient method to check if a notebook is enabled. And again, there's a few additional methods that we'll also share, and some of them we're building into the product, because so customers of Wiz will be able to do it like out of the box without the need to use this kind of undocumented methods on your own. You'll get it from us. So that's number one. And again, you're more than welcome to actually just sample this out. Take a few databases that you have and try it out. Most chances that databases created after February will have an answer, will have a domain, and databases created before February would not have a domain. And if you run this and you get other results, please share with us. We are experimenting, we are researching this with customers. So we are here for you. So please try it out and let us know. So that's how we discover the affected accounts. Now, the second step is, okay, I know my affected accounts. Second step is regenerating the keys themselves. So when we talk about keys in Cosmos DB, there's two keys, primary key and secondary key. So in essence, the primary key and the secondary key are the same. There's just two keys. There's no difference between them. But the vulnerability affected only the primary key, right? The only key that we got access to within the notebook environment was the primary key. So actually the secondary key is safe. And there's no need to replace the secondary key. The only need to replace is the primary key. And that, again, it's an opportunity to change everything, but it does save some work because it was not exposed. And so that's why we're focusing when we say replacing primary key. It is because that was the exposure. So as we said, the secondary key is safe. The primary key is the one that needs to be replaced. Now, best practices to replace keys. It sounds easy to replace a key, but in reality, it's not easy to replace a primary key. That's why we need to make sure we are ready for a long process. It's not something that all teams can do immediately. If the tool was built using like a key vault, right, then it's pretty easy. You just go to the key vault and you switch, basically flip a switch, right? You just change the content of the key vault to contain a different key. That's easy. But if you didn't use a key vault, and obviously I would recommend to transition using a key vault because that's much safer, it's more secure, and also it's here, as you see here, it's much easier to revoke, right? If you're not using a key vault, then A, consider using key vault, and B, your process now is going to be more complicated, right? Because so basically what we are, the recommendation is that to update all apps to the secondary key, right? So basically transition them so you don't have downtime, transition them to the secondary key, regenerate the original key, and then replace back to all of the apps to use the main key, right? Now, this is not easy because you need to make sure you know all of the places that are using the key, right? Because you have to replace them and you have to replace them twice. And each action here may take a while to actually complete. So, and you want to do it without downtime. So the developer teams, this might take time for them to do, especially if it's old applications, right? And they don't exactly know where is the key being used and so on. That may be a complex change. And that's what we are also discussing the second step, which is the network limitations, because it's a really important mitigating control that might be effective immediately, even before we are able to perform the key regeneration. And again, key regeneration, if you have key vault used everywhere, it's easy. But key regeneration, if you don't have key vault, is a complex task. And if it's a production application, it's not easy to do. And that's why, again, when you think about it, keys like these, those primary keys, it's basically a shared secret, right? It's just not a secure method to work with databases. It has no user and password. It's just one shared key for everyone. It's really hard to revoke it. It's really hard to monitor who's using it and to perform auditing. And that's why if you have to use it, at least use it in a key vault because it at least provides you some protection, some abstraction, and then it's also easier to revoke. So that's basically the process. If you have a key that you have to regenerate, you will have to go through an update process for the apps and then regenerate and then switch back, which is definitely not a fun task to do, especially across all of your applications using Cosmos. Now, in general, I would say just remember that if you regenerate the key, once you click on this button, there's no going back, right? So before you click on it, make sure that you transition all of your applications to the secondary key. Otherwise, there's a downtime and there's like no way to fix it. You have to quickly find where's the code that's using it and then switch it to the other key, right? So this is a click that there's no way back, right? So we need to understand, we make sure that we understand that. Of course, if we have a place to test it out in test or staging, that would be better because there's no going back before you click that button. That's why this process is not so fun and quick as we would love to, but that's what we have to do. Okay, any questions on the discovery or key regeneration before I move on to just the piece about networking?
There is a quick one regarding what is the network risk when it comes to the discovery?
So the network risk of the Cosmos DB, like the exposure risk, and how it affects the risk on the database, or a network risk in terms of just the discovery process, just running this.
Once I see the revised answer, I'm going to stop.
So basically, in just the discovery process, running the NS lookup, of course, no risk at all. This is a very safe operation to do. It has no network impact. It's just NS lookup. So you can do it without any hesitation, just run it. There's no network risk, right? Also, this doesn't say anything about the network exposure of the database. We'll talk about it when we get to the Wiz section. This just checks for you one thing. It's a passive way to check, very, very easy passive way with no implications. There's no concern running this check, but it just checks for you if this Cosmos DB is at risk of the vulnerability. That's it. Okay. Any more questions before we move on to the network limitation part? Okay. So just when we actually perform the regeneration of the keys, basically what you see here is we are able to track, and we also discuss it in the process that we built for Wiz. You can see in the logs, because this is the control plane logs, you can see the logs and the list of IDs, right, that are being actually rotated. We built for you a PowerShell script and also a Wiz script, basically that scan your environment and give you the list of Cosmos DBs that performed key generation and Cosmos DBs that didn't perform key generation, right? And we also integrated that into Wiz, what I'll show you in a few minutes, basically to give you the entire end-to-end process. Every time you run the script, it will update Wiz and basically give you a view across your environment of what is my current situation in key rotation, right? Because you can ask the developers to rotate. How do you know if they did it? So this script will allow you to do it, and it also updates Wiz, so you can have a really end-to-end process using the script and Wiz controls. So just touching the last topic of the general mitigation before we move to the Wiz mitigation, which is the network. So when we talk about network and Cosmos DB, so let's say the following. You must use a firewall because you don't want Cosmos DB to be publicly exposed, right? And this is critical. We need several lines of defense. We never want the database to be publicly exposed. Again, remember, in my view, this vulnerability just proves out a fact that you always have to do in any case, right? Like we have a built-in control in Wiz, even before this vulnerability, on a medium risk for Cosmos DBs publicly available, right? But this just shows you why we are giving this a medium risk. Why? Because here, for example, if an attacker got access to your primary key, it's easier for the attacker to get access to your data, right? So we should always make sure that we have several lines of defense, not a single line of defense, because a single line of defense will always fail, right? So that's why using firewall and VNet is so critical. The problem is that the firewall in Cosmos is an IP firewall. An IP firewall doesn't work so well in cloud. What does that mean? It means that when you will try to use this in Azure, you'll run into a few problems. First of all, the recommended way is to use what we call a VNet connection or a private endpoints. So basically, we have private endpoints, we have service endpoints. Just to simplify this, we want to allow Cosmos DB to be accessible only from specific VNets, right? That's the best way. Instead of managing IPs, it's better for us to manage VNets, right? So you should define specific VNets that can access your Cosmos DB. Now, what is the problem? The problem, as you see here on the bottom, accept connections from within public Azure data centers. Most deployments today have this checkbox enabled. And why is this a problem? Because many Azure services require this. Why? Because they don't have a static IP. They have dynamic IPs. Because they have dynamic IPs, there's no way to open them in the firewall. And so Microsoft gave this checkbox. But this is a really problematic checkbox. If you click this checkbox, you should consider your database public because anyone can access it, right? We talked about a cross-account vulnerability. So that means that an attacker already has an Azure environment, so they can access your database. Even if it's not accessible from AWS, if it's accessible from any Azure account, it's definitely public. And for the risk assessment of this vulnerability, I would consider it as risky as a public database because any attacker can get Azure account. That's not really a barrier. That's not really protection. That's not really a firewall. So many customers using the firewall on Cosmos DB use this checkbox. And I'm sorry, this checkbox is, and again, I'm saying that because I'm looking at the network protections provided by Cosmos DB. This checkbox is not, in my view, especially when we look at the vulnerability. And it's always good to look at the risk and analyze protections compared to a risk, right? When we look at the risk, we can say this protection basically means the entire firewall does not give me any value. Because every database that had this checkbox turned on, the attacker can still access the database and read the data. That proves that this exception basically reduces most of the value of the firewall in general. And sadly, most customers actually do use this exception because that's like the default recommended setting. And in my mind, this is not acceptable. Any questions on that? That's an important topic. So I do want to stop for a second to get any thoughts about that. Any questions, Soral?
No questions in the meantime. If somebody also wants to ask live, you can raise a hand. I'm going to permit speaking. Yes, there's one question coming up right now. Does Wiz as a product check for this configuration and notify? And I'm smiling, and Ami, you can take the answer.
Yes, and we'll see. We'll show you in 2 minutes. I'm going to jump to the product. And I'll show you all of the built-in configuration checks that we added to the tool. Some of them were already there because we do very deep analysis of network, as you know. But some of them we added just for ChaosDB. Some of them are unique to Wiz because we're researching this for a long time. So I'm going to show you all of these in a few minutes. Okay, one last comment before I switch to Wiz. So private endpoints, just as a last comment, are an additional layer, an additional way to access Cosmos DB. It's in my mind, this is the future. Private endpoints are the most secure way to access resources because there is no external exposure. What's important here to remember is that even if you use private endpoints, you have to go to the firewall and enable the firewall and block all access, right? Because if you didn't do that, the database is still public. You need to block all access and configure a private endpoint. The beauty of private endpoint is that it doesn't require any firewall rules because it's internal. It's accessing from within the network. And again, if you want, and let us know after this session, more than willing to do like an entire session on networking in Azure. It's a very complex topic, but just for this session, what's important to mention is that, yes, private endpoints are great, but eventually what I'm checking, and we check that in the product as well, is that the firewall is closed. That it doesn't allow anything because if you have a private endpoint, but you didn't close the firewall, it's still open, right? So that's why we are tracking this. Of course, I expect all databases to use only private endpoints. So we check also that in Wiz. Okay, so now I'm going to switch to mitigation with Wiz, and I'm actually going to show you in the product. So before I do that, any last questions?
There's a quick one. Did this change from trusted Microsoft services to public Azure data centers? And I think we're referring to the Azure UI.
This one, public Azure data centers to, like changing the UI?
Yeah, did they change the naming just recently because of that? Or are going to change, as far as you know?
So first of all, it's a good question. I don't know. And what we're saying, you can actually even in the documentation, they added a comment about this, but in all of the recommendations, they say to use this checkbox. So I want to be very clear. I don't think this checkbox is secure, but it does mean that it breaks connectivity to some services in Azure, and you know, sometimes there's a trade-off, and sometimes it's not secure enough, you know. So in my mind, this checkbox, even though it breaks access to some configurations, should not be used. Okay.
I see no hands, so we can continue.
Perfect. So let's switch to the fun part, Wiz. Okay, so we've done a lot of effort in Wiz to provide you the most complete experience for ChaosDB. And I'm going to take you through this quickly now. We are also releasing, as part of this big release, the Threat Center. And the Threat Center will have detailed documentation on every new vulnerability that we find, and also vulnerabilities published in the world. So this is like a completely new value proposition from Wiz, and you will see there highly detailed explanations of how to remediate ChaosDB, and it will be live, right? So any questions that we'll get from you, from customers, and we are getting tons of them, we are going to improve this documentation and add more and more answers for you, right? There's both the Threat Center and the documentation. I'm going to jump and show you that now in the demo. So just the 4 components that I'm going to show you in the demo: the Threat Center, and the details about this vulnerability, and other advisories that you'll see how the Threat Center is built and why it helps me for this vulnerability, but also in general, this is a long-term value from Wiz. And it shows the way that the Wiz research enables and enhances Wiz in a way that's very different from legacy tools. The second piece is the high-risk database detection. So basically leveraging the exposure analysis that Wiz has with all of the flags that we just talked about to flag for you which are the findings, which are the Cosmos DB accounts that you have to fix immediately, right? Those are the ones that are at the highest risk, meaning that they have exposure, public exposure, right? Now, the third component that we'll talk about is the database configuration analysis. And this goes back to the different flags that we talked about. The configuration checks are built now into Cosmos DB. Some of them we actually added as part of ChaosDB research, and show you exactly the things that we talked about. Is it using private link? Does it allow wide access, and so on? And the last part I want to show you is a really cool process that we built to show you how you can manage the key regeneration process in your organization using Wiz. So that's the flow that I want to talk about right now. So I'll switch to the demo, and while I do that, feel free to also ask questions like you've done so far. It's been great.
I mean, just an update while you're switching. The latest check was just published now.
Amazing. Okay, so let's start. The first new piece of Wiz is the Threat Center, right? So the Threat Center was just released as part of the ChaosDB preparations, but it's a completely new part of Wiz that we'll talk about a lot also as we go forward, because it also highlights the way that Wiz sees the world, right? Wiz shows you your critical risks in the cloud, and Wiz is built on threat analysis and research, right? So when we look at these threats, so you can see also we have a database of threats, and we will provide you ongoing support on new threats. And each threat here, as you see, let's actually follow the link, has a detailed analysis by Wiz Research, right, of the threat. So on ChaosDB, you have here a detailed overview of the vulnerability, of the flow that you have to do, right? So it's accessible to the internet. Is the notebook feature enabled? If it yes, then it's high risk and we'll give you this as a control. If not, can you replace the key? Okay, so you should replace the key. If you can't, then at least perform some limitation. So you really have and you'll have that also for future risks. And here you have the details. Now I'll walk you through them also in the product itself, but you will see this and many of the components that we talked about are already here pre-built with all of the different remediation actions. And I'll show you in a second also the actual process of seeing what keys were actually regenerated. So let's start from the beginning. We have this threat center. What does this threat center shows us? So we have the ability to, first of all, zoom in on the most critical databases at risk that I have to fix, right? So in this environment, basically I have one exposed Cosmos DB account. This is the account that I want to start from resolving. Again, as you remember, a database server running Azure Cosmos DB with an application endpoint, meaning that it's fully exposed to the internet, highest risk. So it's easy for me to see my highest risk and immediately prioritize these databases that I need to regenerate their keys for. So that's number one. So we saw the threat center, and of course we are using the Wiz engine to analyze internet exposure. And by the way, I don't know if you saw this new section on insights in Wiz. Basically, again, it affects all resources, so it's really cool and really helpful. In our context, you see, I have a Cosmos DB account, it has internet exposure. I can click here, go to the exposure path, and I can see the Wiz analysis of the exposure. Again, remember that we do deep analysis. So if this wasn't publicly accessible because there were firewall rules, we actually analyze the rules, right? So we analyze firewall rules. We analyze different checkboxes that we saw before. We flag it as accessible if it's really accessible, right? So this is flagged as a high risk database that you have to fix, right? So this is number one. We have a built-in finding in Wiz to track these databases and prioritize them. Those are the databases you have to go and prioritize the key generation for them as quickly as possible. So that's number one. Now, second piece. Okay, so we have exposure analysis. We can see all of the databases that we have. The second piece is also configuration analysis, detailed configuration analysis. So under the configuration tab, of course, we have the built-in configuration checks. Let's see the configurations that we have on this database. So here we have, and again, every example that we talked about in the network, Wiz analyzes that for you and gives it to you as a built-in check, right? So we check, does this database use firewall rules? Does it have any firewalls enabled, right? If not, it's a detection, right? Also, does it use private link? If not, that's a detection. You should aspire to have all databases, not public, using firewall rules, using private link, right? And all of these give you additional insights into the specific configuration of your Cosmos DB, right? So we have the threat center. We have ability to zoom in on the specific Cosmos DBs that we need to prioritize. And we also can build a really easy view into, okay, show me all of the Cosmos DBs that I have that are not using firewall at all, right? So again, this is an example of this configuration. I can check, show me all of my databases. And again, in this environment, I have one database has this that is not using firewall, right? So we have configuration layer analysis, and you can use Wiz for that. And you have, of course, exposure analysis to really get the higher level analysis of critical risks that you have to fix and prioritize. And again, you can now start all of that from the threat center and zoom in on those. So I jump to the slides just to summarize what we've seen so far before we move on to the last part, which is, okay, but great, I have visibility, I can prioritize. How can I also manage my key regeneration? So while I'm switching, any questions? So, so we talked about the threat center a bit, and we saw how we are leveraging the built-in with engine that is, again, probably one of the only engines in the world that does the deep analysis that can really flag for you exposure of databases based on all of the firewall rules and so on. You know, we have that built in Wiz, and we take into account all of those multiple options that Azure has. And this allows you to immediately zoom in on those and prioritize those to fix. So this is the exposure analysis. We also talked about the configuration rules overview, right? So the private link, firewall rules usage, so you can get to the visibility of that layer and say, you know what, for Cosmos DBs, because it's urgent, I want to make sure that I have no Cosmos DB that fails on firewall checks, or I want private links. I would admit that it's harder. So I would say that as something that for short term, I would focus on everyone at least having some firewall rules configured. And now I'll move on to the last piece, which is, okay, we found the databases, we prioritize them. Now I need to regenerate the keys. How can Wiz help me to do that? So before I move to that last part, which is really, really cool because we really help you end-to-end process, are there any questions?
With a short one, does Wiz identify if the Azure fix of the vulnerability is applied?
Okay, so that's a good question. The Azure has no fix to the vulnerability. Okay, Azure basically just took down the vulnerable service. They took down Notebook. So in practice, until they take back the Notebook, you cannot redo the vulnerability, right? The attacker cannot leverage the vulnerability because this entire feature does not exist since we reported to them from 14th of August. The feature does not exist. So we were surprised they just took down the feature, but basically the feature is down. So the vulnerability doesn't exist. What is the risk? The risk is someone going to use your keys because they were exposed, right? So, and that Microsoft did not fix. That's why you have to fix it because they cannot change the keys for you, right? So my answer would be yes, with checks for if the database is actually vulnerable because it has Notebook enabled, and Wiz can let you know prioritization. And the key here is about regenerating the keys because actually leveraging the vulnerability again is not possible to anyone anymore. Any more questions?
Looks like you're good to go.
Okay, great. So okay, so we have, let's summarize. We saw how do I discover Cosmos DBs and how I pinpoint those that are affected and because they're highly exposed using the Wiz exposure analysis. We also saw how I leverage configuration. Okay, that's great. That helps me with my step of network limitation. That helps me with building the list and prioritizing the list. But how do I know if they perform key regeneration, right? So key regeneration is not accessible via the API. So we had to build another step for you, another script that you will have to run in the Azure CLI. And we've integrated that script into Wiz. So it does require another step for you. And I'll show you that in the documentation. But once you run it, it will automatically update Wiz. And that gives you the power to basically review every time you run the script, what is your status, and basically define a new query that will basically give you the visibility of am I exposed or not. And let me show you how we've done that. So I'll switch to the documentation and actually show you. Okay, perfect. So going back to the documentation. Great. So in the section, and I'll explain the section as well here. Let me show you. We give you an end-to-end process for key regeneration. So basically, what you see here is a script, very simple script, which is called mark rotations. This script, you have to download the script and run it. And once you run it, you can see what it does. It basically adds a property to the Cosmos DB account that says key rotated or key not rotated and when you run the script, right? So you will have to run it to update the nodes, but this gives you a way to automatically and very simply use the script that we've built. And again, you just have to download it and run it with the correct service account. The ability to now get a visibility into Wiz, and let me show you how this works.
Just a quick clarification as well. The script also checks if the keys were rotated after the discovery of ChaosDB. Exactly.
Now, so see how beautiful this is. I'm looking for database servers with native type equals Cosmos DB account that their node says they were not rotated, right? So I see here I have 4 databases that were not rotated in my environment, and I want to now zoom in on them. And of course, I can now use this and also, use the Wiz capabilities, right? I can zoom in on those that are accessible from the internet. Voila, right? So this becomes another property, and this property is simply exactly what you're missing. So once you run the script, you can run it, and it will update the nodes, and you are able now to use Wiz to create issues from this and automate your process and get visibility into your regeneration process and status. And all you have to do is basically run the script from the Azure CLI. It will update this property, and now you can use the Wiz controls. You can define this as a control and track that, right? Of course, you will have to rerun the script, let's say after a day. It's not because it does require you to update the nodes, but you will get from here a continuous update of your status. You can create a control from this, and you can create issues from it. You can mark it as a critical issue, and you have an end-to-end flow. Any questions before we run out of time?
There was one in chat. If we don't use Jupyter, will Microsoft automatically enable it when they fix it?
That's a good question. No one knows. I think Microsoft doesn't know the answer to that. I'm pretty sure they won't. Great. Any last questions on the script, on the value that Wiz provides? Everything that we showed here is also available through the documentation. Go to the Thread Center, ask us questions. We're here to help. Any last question? Okay, so I want to summarize. First of all, thank you all for joining today. We showed you the researchers actually showed you the vulnerability, and we talked about how to remediate it. What you saw in Wiz is basically discovery of high-risk assets, prioritization, configuration analysis, and even an end-to-end process to regenerate your keys. If you have any questions, please feel free to ask us through the chat in Intercom, in the portal, through the emails, through Wiz Research. We're here to help. Thank you very much.